All right, here we go.
Sweet.
All right, let's just start off here with the product rule. If you multiply the bases, then you add the exponents. 4 times 3 is 12. X to the fifth times x to the third. The x stays the same, does not change. And 5 plus 3 is 8. So if I have x times x, what would that give me? X squared. Why is that? Because 1 plus 1 is 2, right? All right, let's look at these. Still in our packet here, okay? All right, so 2 to the third times 2 to the fourth. The 2, notice that the 2 stays the same. That did not become 4. The base stays the same, and 3 plus 4 will be what? 7. All right, let's look at this. Now, in the book, this will not be written there. But my point is that you'll have to remember that it is there. Okay? And so 8 times 8 to the third, I keep my base the same, and 1 plus 3 is 4. Now, if I'm working this in a problem, in context of a problem, I would not leave 8 to the fourth. I have to know what 8 to the fourth is. That's not one of them I had you memorize. So use your exponent button and tell me what is 8 to the fourth.
1096.
Right. This next problem does not have like bases at all. I cannot add the exponents if I don't have like bases. To simplify that problem, I just have to work out 4 to the 7th and 9 to the 6th. So using your exponent button, what is 4 to the 7th?
That'd be 16,384.
Does anybody agree?
Yes.
All right, and then 9 to the 6th?
531,441.
Does anybody agree with that? Would you multiply those together?
That's I gotta count the numbers to see what I start at.
8,707,129,344.
Billion.
Do you agree?
8 billion, 7 billion,
707 million?
707 million, 129,344.
All right. So in that case, you don't leave the exponents, but you also cannot use the product rule because they do not have like bases. Does anybody have a question? All right, let's continue on. If I have, yes, sir.
I don't know what Dalton's saying.
All right, the question is really back on this particular problem right here. This is a coefficient. This is a coefficient. No, they don't have like bases. I did not add their exponents, but 4 to the first is 4, 3 to the first is 3, and 4 times 3 is 12. I didn't add their exponents. Does that make sense?
Okay.
I didn't add them. Like on this next problem, I kept the 2 by itself. I said that would be, to the third would be, well, I didn't actually go further with that. 2 to the third times 2 to the fourth, 3 plus 4 is 7. Now, I could have gone on with that and simplified that. If that was part of a problem, you know, I had all my rules mixed up and that was part of a problem we're going to work, I wouldn't leave it that up. I wouldn't leave it 2 to the 7th. I'd make it 128. But the only time I can use my product rule is when my bases are the same. All right, now we're looking at when the bases are variables. When the bases are variables. So I think most students have an easier time when the bases are variables than they do when the bases are numbers, to be honest with you, because you want to do all kinds of stuff with numbers, and y is just y. All right, and so this will be y to the what power? 7. And this would be 5, and again, I've got to use my product rule, and if I'm multiplying the bases, what do I do with my exponents? Add them, and I just add them. Even though they're not like terms, I just add them together, m plus p. All right, would you guys try these 4, and we'll do them for dollars. All right. What's the answer? 3 to the 5th times 3 to the 1st.
747.
I'd have 3 to the, what power first?
6.
3 to the 6th. And that is what?
729.
729. You guys agree? Anybody have a question? All right, what about 8 squared times 8 squared?
It would be 8 to the 4th, which simplifies to 4,096.
4,096? Is that what you said? Do y'all agree? All right, z to the 6th times z to the 3rd. Z to the 9th. Can't go any further than that because I don't know what z is. And then a to the z power times a to the 3rd.
A to Z plus 3.
A to the z plus 3. You guys agree? See, the using the product rule is simple. Yeah, when we put it together though, with bigger problems. So just remember what the product rule says. All right, now let's talk a little terminology. A monomial is a number, a variable, or the product of a number with one or more variables. For example, 7 is a monomial, but because it does not have a variable with it, we refer to it as a constant. It is a constant monomial or a constant term. You might hear the word term used in place of monomial. Y squared, just a variable by itself. Even though it has the exponent of anything, it's still a monomial. And then this 2xy squared z to the 3rd is a monomial. It's like having a first name, a middle name, a last name, and a junior. Still one person, okay? This 2 is the coefficient, x to the 1st power, y squared, and z to the 3rd. Everything's not to the 3rd, right? How would I make everything to the 3rd? I have to put it in parentheses. So just because that last exponent is there doesn't mean it's to the 3rd power. That just goes with this term. If I want it to go with the whole thing, I'm going to put it outside parentheses. But that's just what a monomial is. All right, to simplify means to remove parentheses and combine like terms. So we will multiply on these when we simplify. We're just going to be removing parentheses by multiplying. All right, let's look at these in your packet. 5t, and again, that first power will not be there. And then negative 30t squared. All right, 5 times negative 30 is negative 150. Has nothing to do with the product rule. Those are coefficients, and I just multiply them normally. And then t is to the 1st, and t is squared. Using the product rule, when I add when I multiply the bases, I add the exponent, so negative 150t to the 3rd. Questions about that? Okay, on this problem, I have 3 terms that I'm going to multiply together. I multiply their coefficients. This one will probably not be written in your book. Neither will these ones as exponents. Negative 4 times negative 1 is positive 4. Positive 4 times 3 is 12. And then a squared and a to the 1st. When I add those together, I get a to the 3rd. B to the 1st and b squared, I get b to the 3rd. And c squared and c squared would give me c to the 4th. Does anybody have a question about those? All right, would you guys do these 2 problems for dollars? All right, it is acceptable when you're writing the answer to put your variables in alphabetical order. That's what usually we would do. Would it be wrong if I didn't? No, but it just wouldn't be normally acceptable. You want to do what you usually do. All right, what about the first one?
180 m to the 3rd and p to the 2nd.
Right, P. There's only one P, so I just bring it along, right? All right, and then the last one here.
160x y squared z to the 3rd.
You guys agree? Does anybody have a question? Can I write a first power with that x? Yeah. Do we normally? No. So.
Do you have to do that in like order like 8 times negative 10 first?
Oh no. What property says you can multiply in your order? Starts with a C. Community. Or what property says I can group them however I want to? Starts with an A. Associative. So that's a great question. You can multiply in any order you want to. All right, let's look at example 3 in our textbooks. see, we're in lesson 8-1. So example 3 is on page 372. If you've had any biology, you know that bacteria multiply exponentially or very quickly. And that's why this is English chapter.
Might be back for eating that lunch.
Yeah, Alright, suppose that a colony of bacteria doubles in size every hour. If the colony contains 1,000 bacteria at noon, how many bacteria will the colony contain at 3 p.m. and at 5 p.m. of the same day? Alright, so this is exactly, you'll do this again in Algebra 2. My finance class is doing this now because money is sometimes compounded, using exponential equations. And so this is always your beginning amount. This is your final amount. Where does the 2 come from? Because the problem says that these bacteria are doubling, and N represents time. Alright, so if we started out with 1,000 bacteria, and the question is how many bacteria will there be at 3 p.m. If this original colony started at noon, 3 p.m. is 3 hours later, and 2 to the third is 2 to the third is 8, and 8 times 1,000 is 8,000. So that 1,000 bacteria in 3 hours became 8,000 bacteria. Alright, so how many bacteria would we have at 5 p.m.? Well, again, I started out with 1,000 bacteria. They're doubling every hour, and from noon to 5 p.m. has been 5 hours. 2 to the 5th is, somebody said it, what? 32, and 32 times 1,000 is 32,000. How many hours are we at school in a day?
8.
So what's 2 to the 8?
That would be,
256. What's 256 times 1,000? 256,000.
We're